In this example, we are using Newton's law of cooling formula to do this problem. The information given is, the first part is asking us to find a function that models the temperature T hours after death. And the second part is like asking us, if you know the body's temperature now, then how long ago was the time of death, okay? So let me dissect this formula given here, and first let me understand this. So here it's giving me T of T is equal to S plus D0 e to the power of negative KT. The negative in there is saying it's cooling, so as time passes the temperature is going down. Therefore, it has to be negative. Now D0 is the initial temperature, and this is where I think you have to be careful when you do the problem. So D0 is the initial temperature, which is the difference between an object and its surroundings. So this will be whatever the initial temperature of the body is minus the surrounding temperature. Something that you have to be careful about inputting. And T of T, this would be the final temperature, and Ts, this represents the surrounding temperature. So, or we can also call this the room temperature. K is a positive constant because the negative is there in the formulas. Therefore, when you just find K by itself, it will be positive. And this is a constant, and T is the time. Okay. So the first step of the problem is to find the K value, so you can write the model to this equation. And the second part will be, you'll be using that model to do the rest of the problem. So I'll go back and read the problem here. It's saying Newton's law of cooling is used in homicide investigations to determine the time of death. The normal body temperature is 98.6 degree Fahrenheit, and we know that, right? Immediately following death, the body begins to cool down. It has been determined experimentally that the constant in Newton's law of cooling is given as that value, K equals 0.1947. So the K value is given to us. Assuming time is measured in hours, suppose that the temperature of the surrounding is 60 degree Fahrenheit. What is the model? So here I don't have to find K, but what I need to know is what is the D0 value. Okay, the D0 is the initial temperature, which is 98.6 minus the surrounding temperature, which is 60 degrees. So D0 should be 98.6 minus 60 is giving me 38.6 degree Fahrenheit. So with this information, if I go back to write my formula, Ts, which is the surrounding temperature, is given as 60 degree Fahrenheit. My K value is given to me as 0.1947. So I can write the model T of T equals 60 plus 38.6 e to the power of negative 0.1947 times T. Okay, so the first part was not too bad, but the second part, the question is asking if the temperature of the body is now 74 degree Fahrenheit. So what that means is if T of T is 74 degree Fahrenheit, how long ago was the time of death? So that's asking me what the T value is. So to do this problem, I will set up the equation again. So 74 is equal to 60 is my room temperature, which is not going to change, plus the initial temperature. The D0 value is going to be 38.6, which is again 98.6 minus 60. Okay. E to the power of my K value is the same, 0.1947. Remember to put the negative sign in the exponent. And T is my variable that I'm looking for. So I would write that as T. So this is my variable that I'm looking for. Okay, here also this is an exponential equation. Now my exponential piece, this is my exponential term. Okay, so first I need to isolate everything to the other side. So first step would be I would subtract the 60. So 74 minus 60 14 is equal to, I have the 38.6 e to the power of negative 0.1947t. The next step would be I'll divide both sides by 38.6. Okay, that'll eliminate my right hand side. So I'll have 14 over 38.6 is equal to e to the negative 0.1947t. Now next step would be to take ln both sides. I'll use a different color here. Take ln both sides. My left hand side would be ln 14 over 38.6 and my right hand side would be ln e to the negative 0.1947t. This would lead my right hand side to be negative 0.1947t and my left would be ln 14 over 38.6. To find t, I'm going to go ln 14 over 38.6 divided by negative 0.1947. So use your calculator. ln 14 divided by 38.6 close parentheses divided by negative 0.1947. So t is approximately, it says round to the nearest whole number, so I would say approximately 5 hours. That should be the answer to this question.